Now, some useful theorems. The proofs are available in the book. You are not responsible for the proofs unless that I am proving them in the class. Let A belongs to Rm by n. B belongs to Rm by k. Sorry, n by k. Then the norms of alpha norm and beta norm and gamma norm are called mutually consistent if norm of AB, an alpha norm of AB is less than or equal to norm beta norm of A multiplied by gamma norm of B. Then alpha, beta, gamma are considered to be mutually consistent. The matrix norm is said to be consistent if, for the above A and B, the norm of A and B is less than or equal to the norm of A multiplied by the norm of B. The Frobenius norm and the P norm for all the P's are consistent, matrix norms. So here if I have F or P, this operation is valid. Let's give an example of non-consistent norm, which will be a mixed norm. The mixed norm is a matrix norm, but is not consistent. Well, actually, this mixed norm of 1 and infinity, and a numerical example for that is given A is equal to B is equal to a 2 by 2 matrix or 1, then mixed norm of 1 and infinity of AB is 2, while the mixed norm of A and B 1 and infinity is 1. Multiplication of them are 1. useful, cool notes. What is the P norm of IN? This is one for any P. What is the Frobenius norm of IN? What was the Frobenius norm? How can I calculate it?
Trace.
Huh?
Trace.
Square root?
Yes. So that's one.
No. It is the square root of n. Because how many ones are we? Everything is 0 except the elements of main diagonal. How many of them do I have? N of them. And the results under the square root. A very important inequality. You know, guys, do you know why we need to know inequalities? Why do we write inequalities? Actually, in our book, page 61, there are lots of famous inequalities. But why do we need to know inequalities?
They enable some preconditions for proofs. Triangle equality is used for it.
I mean, no, like in engineering or in physics, in practice, why do we need to know the inequalities? I mean, forget about the proofs in mathematics. What does an inequality give you?
Upper bound.
It gives us a very good understanding of the boundaries, maybe upper boundary, lower boundary. So it's very important because sometimes you cannot calculate something. But you know that it is between this and that. A very famous one, which maybe you have used it quite a lot in calculus, was when we had this. The limit of x goes to infinity of sine x over x. What is this result?
Zero.
It is 0. Why it is 0? Because this is a number divided by infinity and this is 0. What is sine infinity?
Undefined.
We don't know, but one thing we know. It is between -1 and 1. So because it's between -1 and 1, so definitely it's something which divided by a huge number, so the result is 0. So knowing, sometimes we don't know what the value is, but having the boundaries is very, very useful. So in page 61 of our book, review page 61 of our book, it has lots of good, very useful inequalities which you might want to use it. In addition to that, for any A belonging to R m by n, the norm true of A is always between these two numbers. It is always between the maximum element of the matrix. It's bigger than the maximum element of the matrix. It is smaller than the maximum element of the matrix multiplied by square root of n by n, which is the size of the matrix. And one final property. The norms, the Frobenius norm and norm 2 are unitary invariant. In other words, for any A belonging to R n by n, and for all orthogonal matrices of Q belonging to R n by n and Z belonging to R n by n, then we can write this. QAZ, the alpha norm of QAZ is the norm of A. Alpha norm of A if alpha is either Frobenius or 2. When you see something like this, who comes in your mind? Our old friend U sigma V, right? Orthogonal, a matrix. So in other words, if you have to calculate this, you can calculate this. Right, for A. Do you know how to prove it? Do you know how to prove it, Ike? (1579), the homework questions from the chapter 7 that you have to solve. And the question number 7 is, prove this. Do you all have the e-book of our book? So you don't want me to scan the book and put
So 1579.
1579. 1579. Do you have any questions? If not, this is the end of the lecture for today.